Jai Hind everyone. I, Suvarna Mujumdar, Assistant Professor in Electronics and Communication Departments, welcome you for a lecture on 8253 Programmable Timer Controller IC. This IC, that is 8253, it is used so that it can provide a facility to the microprocessor for generating the delay as well as for counting an event. This is a peripheral IC which we will interface with any microprocessor or microcontroller so that it can enhance the feature of microprocessor for controlling a delay or generating a delay element, or as well as it will help microprocessor or microcontroller to generate a signal related to delay or square wave generator like signals. We can use 8253 to generate this signal. So we will discuss about 8253 and the another version of programmable timer counter IC is 8254. So just we will have the difference between the 8253 and 8254. 8253 is operating at frequency from 0 to 2.6 megahertz, while 8254 will be operating at a frequency from 0 to 10 megahertz. This is the basic difference between 8253 IC and 8254. Next is the technology. The NMOS technology is used to design the 8253, that the transistor used to implement the features or structure of 8253 is by NMOS technology, while in case of 8254 it is from HMOS technology, hybrid technology. Now, in case of 8253, we don't have a readback command, and it is not which is available with 8254. The readback command is used to read the current status of the IC that we are programming this IC. So, what will be the current status and what will be the count? So, in case of 8253, this facility is not available with us, but in case of 8254, we have this facility. Now, in case of 8253, read and write of the same counter cannot be interleaved. That we will see what is 8253 and then we will find out that how this read and write is not applicable in 8253 while it is available with 8254 IC. So we will सोमना जी पेन चाहिए था अच्छा So we will discuss about 8253 in detail, and the block diagram, pin diagram, all are same for 8253. Only the technology node it is different from 8253. So the features of 8253, that it has three independent 16-bit down counter. Whether we can say 8253 or 8254, both of them have 16-bit down counter, means we can have a maximum count of 65,536 in each count. And it can handle up to 10 megahertz clock input frequency, that we can give a DC signal, and up to 10 megahertz as a signal which can count as an event. So if we consider 8253 for an event counter, then in that case we can apply a 10 megahertz signal maximum. Then we have these three counters can either be programmed as a binary counter or we can program as a BCD counter. When we say binary counter, means the count will be in sequence from 4 times 0, that is nibble, to FFF. We say in hexadecimal, or this is the binary counting. But when we say the BCD counting, the counting will start from 0 and it will be in 999 in the BCD, binary coded decimal count. We can say that it is, as I already told you, that it is compatible to all the microprocessor as well as microcontroller also. And we have discussed that 8253 have a powerful readback command which will help so that we can read the current status of count value as well as the programming mode and current mode of the counter. So once we can program the 8254, we have a facility with 8254 that we can in between its execution we can read back the status of 8254. This is the architecture, or we can say the block diagram of 8253 as well as 8254. So here we will find that there are three counters: counter 0, counter 1, counter 2. All of these are 16-bit counter. So we have to first configure these three counter register, and we have to set the command word for this. So we have a command word. For that we have a control word register where we can configure at a time, we can configure one of the register, one of the counter. So if we have to use counter 1, first we have to configure counter 1. Then if we have to use counter 2, then we have to configure counter 2. So we have to write two control word each for counter 1 and counter 2. While writing or while programming this architecture, we have to use this data bus buffer, and these data lines are connected with the microprocessor data lines, and through writing signal, we can activate the writing signal and we can write the command word first. Then we can write the count value in the counter register. So we have to select this chip, that this is the chip selection logic. So hardware circuitry, we have to assign some address line to this signal IC, and from this A1 and 0, A1 and A0 lines, we can configure whether we are dealing with control word register or we are writing something in counter. So we have 4 combinations: control word register, counter 0, counter 1 and counter 2. So to access these 4 different registers, we need 2 values. So we have 2 address lines dedicated for selection of these 4 values: control word register, counter 0, counter 1 and counter 2. Now, for each counter, there is separate clock signal. So these clock signals are used for ticking, that when we say there is one clock, the counter will decrement by 1. Then second clock again decrement. So in this way, it will count the clocks. Once it reaches to 0, that is the terminal count, it will generate the out signal as an interrupt to the processor, that okay, the count is done. That 15, if we say if we loaded with the value with 15, so 15, 14, 13, like this, it will go down for each clock, and when it reaches to 0, it will generate a 1 signal at the out pin. So we at a time we can configure 1, but we can configure 3 of them, and we can have 3 interrupt signal for microprocessor. There is one gate signal corresponding to each counter. These gate signal are used so that externally we can control the operation of the counter. In between, when we initialize the counter, we start the counting, and now in between, if we want to hold this counter, that it has to get some pause value for some time, then this gate signal is used as an external control signal for this counter register. This is the pin diagram for 8253 as well as 8254. It is a 24 pin IC, and from pin number 1 to pin number 8, these are the data bus which is connected to the microprocessor data bus. Then pin number 9, 10 and 11 is associated with the clock out and gate for counter 0. Pin number 12 is ground. Pin number 24 is VCC. 23 is write signal and read signal. So these are the signals connected with microprocessor read and write signal, so that whenever microprocessor is writing something 8253, it will make the signal active low, and if microprocessor has to read something from 8253, then it will make this read signal active low. Chip selection. So initially microprocessor has to first select this chip. The address lines of microprocessor are used to connect with this chip selection. A1 and A0 lines are connected with the A1 and A0 line of microprocessor, that is the address line. 18, 17 and 16, these are the 3 for counter 2, and 15, 14 and 13 are for counter 1. So this is the 24 pin IC of our 8253. Now as I told you, we have 4 registers. 3 are counter register and 1 is control word register. So initially we have to first select the control word register. So for selection of control word register, we have to see the value that A1 and A0 will be 1, 1. And if we have to write something in counter 1, in that case, it will be 0, 1. And for counter 2, it will be 1, 0. So if we have 16 address line from A15 to A0. So A1 and A0, if we write 0, 0 and other rest we consider as 0, values only. Then in that case 00H will be the address for counter 0. If we have write 01, then 01 will be the address for counter 1. 10, that is 2H for counter 2, and 11, that is 03H for control word register. So when we have to write program for interfacing, or we have to initialize the 8253, in that case we have to first load this value, that our control word register has to be written in the count. We will write control word register in the value in the A register, and then we out it on 03H. So in this way, we first initialize this 8253. Then if we have to load the data, so suppose I have to load 7 value 07H, then I will out and I will select any of the counters. Suppose I have selected counter 1, then I will out this to out 01H, so that the data will be written in counter 1, and first I have to configure this counter 1 using control word register. This is the control word register format. First 2 bits, that is D7 and D6 bit, these 2 bits are used for selection of the counter, whether we are selecting counter 0, counter 1, counter 2. So if these 2 bits are 00, we select counter 0, and we can configure counter 0 in all the mode. So there are 3 bits which are used for mode selection: M2, M1 and M0. From 3 bits we have 8 combination, but at a time we are now having 6 modes only. And from here you can see that this don't care means it can get 0 or 1, any of the value, means for 2 and 6. Mode 2 will be the working mode, and for 3 and 7 mode 3 will be the working. So there are total 6 mode in which we can configure our 8253. Any of the counter 0, counter 1 or counter 2, we can configure them in any of these 6 mode. And this D0 bit is used whether we want it to be in binary counter, that is it will count 0, 1, 2, 3, A, B, C, D, E, F, that is in the binary values, or hexadecimal we can say, or we can configure them as a BCD counter, that is 4 decades, because there are 16 bit. We can make them as a nibble of 4 bit each. So we have 4 decades. So we can count maximum. Here we have a count from 4 times 0 to 999. That is 4 decades. So we have first select the counter, then we select the mode, and we will select the data bits, that whether we want it to be in binary counter or BCD counter. Now the next thing is how we will write the data in the counter register. Whether we have to write 16-bit data, we have to write 8-bit data, that is lower byte, or higher, more significant byte. And one more thing is there, whether we have to read operation, that I told you that if in between microprocessor want to read the content of counter, that what value that counter is holding at particular instant of time, then in that case microprocessor has to read the data from the counter. So it has to latch that data. So using this D5 and D4, RW1 and RW0, these 2 bits can help us to read the data, or we have to write the data. So if these 2 bits are 00, then counter latch command will be working, that microprocessor is reading the data from that particular micro counter. Suppose we have selected here counter 1, 0, 1, and here we will write 0, 0. So whichever mode it is working, it will latch the content of counter, and counter will latch that value, and we will read that value from the counter value. Now if we have to write the data, so if we make it 0, 1, we will, least significant bit is only writing that we have maximum FF, or we can say maximum we have 99 will be the BCD counting, or in case of hexadecimal we can have maximum FF will be the counter value we can upload in the least significant byte. If we configure as a 1-0 mode, then in that case we will only using higher MSB. Again we have only 8-bit of data, so we can have 99 or we can have FF maximum value. Now if we have to write 16-bit, we have to load a counter value with 16-bit data, that is higher than FF, or we can say it is having 4 nibble data. Then in that case we will write we will select here 1 1 and we will write first least significant byte and then we will load the most significant byte. So we have to first decide which counter, which mode, the mode of the counter, BCD or binary, and the loading value. So if we are, suppose we are using this counter 8253 for generating a delay. So from delay we have to calculate the count value, that how much will be the count value X, we will calculate that count value, and from that count value we will find that the delay is for only one time delay or we have to repeat that delay. So accordingly we will have to select the mode. Now we will discuss about the modes. So mode 0, there are 6 modes. So first mode is mode 0, that is interrupt on terminal count mode. So in this mode we will first upload the register counter with some value. So write signal will be active low in the first clock cycle. So this is the first clock cycle, and then this first clock cycle we have write signal active low. In this figure we have loaded with the value 4. So n will be 4, and after each clock the counter will decrement. So 4, 3, 2, 1, 0. Once it reaches to 0, the output pin that is related to any of the counter, out 0 or out 1 or out 2, whichever counter we have selected, that pin goes high and indicating the interrupt on terminal count. That count is reaches to terminal last value and we have a terminal count, and it will reach high till and it will act as an interrupt to the microprocessor, which is to which this 8253 is interfaced. Next mode is hardware retriggerable one-shot mode. In this mode, again we will load the value in the counter register, and in this example also we have load the value with 4. So when the counter start decrementing, output signal will goes low and it will remain low till the counter is decrementing by the clock. So for 4 we can see that 1, 2, 3 clock cycle it will remain low, and for 4th cycle it will goes high, indicating that we have one trigger or one shot. And this this signal will be used as an output signal for any processor as an interrupt, or we can use this signal to run any other device or activate any other device. Next mode is rate generator. In this rate generator, once we loaded the count value n equals to 4, in this mode it is auto reload mode, or we can say rate generator clock, that after each clock it will generate a pulse and again it will reloaded the count value. So 4, 3, 2, 1, 0 and one impulse will be there, and again this counter will start counting. So again it will be 3, 2, 1, 0 and we will have one pulse. So rate generator will be used as a output signal where we want a multi-loop functionality with all this n equals to 4 or n equals. If here we change n equals to 5, then after 4 clock cycle we will have the output impulse, and till now that time the output clock will be high. Next and most important mode in which we mostly configure our 8253 is the square wave generator. Whenever we want a microprocessor to use as a to generate a square wave or to toggle any LED or any device, then in that case we have to configure 8253 in a square wave mode. So in case of square wave mode, the count value which we are loading, if that count is even, n is even, then for half of the time the output will be high, and for half of the time the output will be low. So for 2 clock pulses, the output will be high, and for 2 clock pulses, output will be low. But if the count value, that whatever the count we are loading, that in second example it is odd 5, then for more number of times, that is 5, we if divide it is 2.5. So for 3, round of figure 3, for 3 clock cycle, the output will be high, and for 2 clock cycle, the output will be low. So in case if n is odd, then this square wave does not have, we can say it is a rectangular pulse, because the on and off period are not same. So if we have to generate a square wave, then in that case, our count value must be even. That is the mandatory requirement. Next mode is the software trigger mode. In this mode, the output is initially high and it goes low for a clock at the end of the count, and the count must be reloaded again. In case of mode 2, we have seen that in case of mode 2, here we see that this output is high and it goes low for one cycle. But in case of mode 0, the output is initially high and it goes low for one clock period at the end of count, and the count must be reloaded for subsequent output. Mode 5 is a hardware trigger mode. It is another, or we can say this mode is similar to mode 4, except that it is triggered by rising pulse at the gate pulse. So when we need to control the functionality of our counter from external source, then in that case the gate pulse will come into picture, and whenever the gate signal is high, then only the counter will start counting and the output is low, and when the gate pulses will trigger from low to high, then only counter will start counting. And if in between the gate pulse goes high to low, again the count will remain at that state, and the next state will start only if gate pulse is triggered again. So gate will control the working or functionality of the counter in this mode. If we have to, that's why its name is hardware trigger stop. That hardware from external signal, we are using the control of 8253 counter. In the readback command format, which is available with 8254 and it is not available with 8253, here we have to check the count value, program mode, and the current status of our output pin. So this command is used to read the status of our counter, the initial counter. So for reading the data, we will use the command in 03H, as our control word register address is 03H. So we are reading in 03H. That content will be available with us in accumulator, and from accumulator we can observe that if this D7 D6 bit is high, then and count is 0, and this is status signal and related to counter 2, counter 1 and counter 0. So we have to select which counter we want to read the data. So from here we can latch the selected counter value, and we will select we will read the data from that particular counter. So the counter 2, if we have to latch the counter 2, then this D3 bit will be high and we will select the counter 2, and D0 bit is not used, it is 0 initially. Count value, if we have to read the count value, then in that case this bit will be 0, and if we have to read the status, that which mode it is programmed, then in that case this status bit will be 0, and we will read the value of that particular count. So we will just revise what we have studied till now. We have discussed about the 8253 programmable timer counter IC. As its name say, it will be used as a timer as well as counter IC. So we can count the event. 8253 is a 24-pin IC. It has 3 16-bit counter, and these are the down counter. So we can program these either as a BCD counter, or we can program this as a binary counter. To program each of these registers, we have to write control word register. So from control word register, we can configure at a time one of the counter register, and using external signal, that is clock, gate, we can control the operation of control word register. So first we have to initialize the counter, then we have to apply clock signal, and then accordingly it will start decrementing the value of your counter register. Gate signal is used for hardware control. So if we have to we selected mode 6, mode 5, then in that case the gate pulse will be in active mode, and externally we can control the operation of any of the counter register. So this is all about 8253 programmable timer counter IC. Thank you.